Okay, chapter 4, section 7. We reached the end. Okay, now, here's the good news for today, folks. It's not as hard as it seems, okay? There's a lot of information in here, okay? What I want to talk about is this word wise, okay? It's an old word that we don't use anymore, okay? You may have heard this term wise when we talk about a clock and it goes clockwise, or sometimes it goes counterclockwise, okay? And this is the same type of use of that old word wise. In this case, piecewise, okay? And it basically is it's saying that it's going in a direction, okay? So what we're going to be doing here by doing piecewise functions are we're going to be given more than one function, and we have to determine which one to use. We're not going to use both, okay? This function is for all of the numbers x, where x is less than 2. Alrighty? This one is the one we use whenever x is greater than or equal to 2. And so they're going to ask us to solve. We're going to put this x inside of here, but not both of them, just one of them. So when x is 2, which one am I supposed to use? Now, if it's less than 2, then I use the top one. But 2 is equal to 2. So I should use the bottom one. Now, all I'm going to do is I'm going to use this bottom equation, x minus 5. I'm going to substitute the 2 where the x goes, and I get my answer, -3. That's all there is to it. You don't have to do it twice. All they want you to know is which one are you supposed to be doing it for? Which piece of the function are you supposed to be using? Now here is x equals -1/3. -1/3 is less than 2. So that tells me that if I'm going to use 2, I should use this one. But if I'm going to use -1/3, I should use this one. So 3x plus 1, I type in 3 times -1/3 for the x. Okay, these 3's cancel. And I'm left with -1 plus 1. And I'm combining them and they have a 0. So I'm going to get two answers. Okay? Because it depends on which one you want me to use. And they tell you which one you're supposed to use. Okay? Now, before I get to the other example, let me go ahead and go through these daily functions for daily exercises here. Okay? As an example. Now, first of all, they want us to pick one of these when x equals -4. Now, which one should I use when x is -4? -4 is less than -2. So I should use the top one. So equals 5x minus 1. I'm going to put the -4 where that goes. This becomes -20 minus 1. And the answer is -21. And then we're done. Well, what about the other one? We're not doing them, both of them. We're only using the one that makes it work. Okay, now notice between A and B, we have the same functions, the same criterion, but this time, what do we do when x is -2? Which should we use? The top one says x is less than or equal to -2. So we've just discovered that's the one we're going to use. So 5x minus 1, we put in the -2 where the x goes. I get -10 minus 1, and the answer is -11. Okay? You don't do them both. You have to say which one it is, and then you just do the one time. Let's do it one more time here. One more time, I'll point out to you. Notice the functions are the same. I'm using the same problem for each one of them, but the number x keeps changing on us. So this one says, which should I do when x is -1? Well, x is -1 is less than, nope, x is -1 is bigger than -2, so I'm going to use that one this time. equals x plus 3. I then type in or put in a -1 where the x goes, and that's how I get the answer 2. Alrighty. Now, let's go back to the front side and talk about graphing for a moment. I don't know how many questions there are for graphing in this section. There shouldn't be that many, so I just don't worry about it. If you're having trouble with it, I can go over it when I later. But for right now, I wanted to show you some of the basics behind graphing. And what we're talking about here is graphing this both pieces. So when you're graphing, you have to do both pieces. That's all. We're going to graph two lines. There are two lines here. This one is y equals -x minus 4, and this one is x. So let's start by graphing this top one. First of all, just looking at this top one, we see that the b is -4. So we're going to have an intercept, a y-intercept at 0, -4. That's right here, right down there. Notice that for this function, the x is less than 0, according to what it says. It does not include 0, so we write an open circle. Next, on the same equation now, the slope is -1, so that means our slope is -1. That means our slope will be -1, which means -1/1. Okay, now, starting from this y-intercept, if I go down 1 to the right 1, that's going to be right here. But if I keep doing that, down 1 to the right 1, I'm actually leaving the graph, as you can see. Okay? So, we consider this. -1 divided by 1 is the same thing as 1 divided by -1. We've talked about this in the past, how it doesn't matter which one is negative. You can move that negative up and down as far as you want. It doesn't make a difference. Why would I want this if it doesn't make a difference? Why would I want this one and not the other one? Because there's more room for that. This would be up 1 to the left 1. So from here, up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. You see? That is much more practical to go that way than it is to go this way. Okay? And I can do that because these two are the same. It doesn't matter if you look at it like we go to the down one and to the right one, or you can look at it like we go up to the up one and to the left one. It doesn't matter. They're the same. We can move that negative to either side. Now, what we have successfully done here, using the slope and the y-intercept, is we have successfully graphed this one. Now we need to graph this one. That's all we're doing. And what does this tell us? First of all, the b is 0. There is no b. Okay, 0. That means we're going to have a y-intercept at 0, 0. Okay, so there's our dot. Notice that for this function, we use a closed circle. Closed. What's our slope? Our slope is 1. Our slope will be a positive 1/1. So from here, we go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and there is our graph. Now, what makes this special? Why are we doing this? Because they want you to practice graphing. Because they want you to see that one function is for each line. And while it could be two different things, all that means is there's going to be two different lines. All right, let's take a look at an example. We have to graph this piecewise function, and find the domain and range. Okay, so here's the boundary line, right at -3. Okay, now here's our first thing, 2x. So this is what we know. This says y equals 2x plus 0. So let's graph this. Okay, now that would be 0. And because this symbol is this symbol, we're going to use a closed circle. And then we're going to use the slope up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. Alrighty. So this, I'm going to do it real light now. That is this line. Okay, but this line only exists for all of the x's less than -3. Okay, so here is 1, 2, 3. Okay, so this would keep going all the way through. And when x is -3 down here, okay, this is our line. Now, what about this guy? Okay, this one is y equals -2x plus 0, right? So we're starting off at 0, 0. This time we're going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. I draw a real light line. Okay. And this bottom one is true for all of the x's greater than -3. Okay, now it's not greater than or equal to, just greater than. So we're going to circle this up. And this is the line. Okay, that's our piecewise. Okay, graphing is difficult, but give it a shot, please. If you do it wrong, we'll fix it. Okay, but if you don't try at all, there's nothing we can do about that. Okay, you're just going to fail. All right, so try your best you can. Good luck, and come to tutoring. Email me if you have any questions.